Okay, once again, my friend, shocker du jour, I do not intend to let you down. However, this could be somewhat disturbing. Let's look into it. I have some new evidence about the volcanism and the pressure that's building up underneath the Earth. And not just here, not just there. It's pretty much everywhere because the Earth has absorbed too much energy, which is heat, which is expansion, and underneath the Earth it's swelling and geysers are going off and volcanoes and Earth is quaking and opening up. They call it slow motion earthquakes now. The Earth is literally opening up like that. It's time to look at this with a whole new set of eyes. And I don't mean to disturb people. I don't mean to upset people. We need to take into course reality, or we're just walking around in circles. Now, they did a whole bunch of surveys out here at Yellowstone. Let's look into it. Okay, the thing they don't know about, I'm telling you right now, that is a creature's body. I don't care what anybody says. That is the thyroid right there. It's just unmistakable. These are the lungs, and they are dense with connective tissue. That's why it's mostly rock. Down here, different story. You're going to have a stomach, not mostly rock. You're going to have small intestines, not mostly rock. Large intestines, not mostly rock. Colon, all of that stuff is down in this area, which is below this, because he's laying on a plane like this. You see how we're way down here, 40,000 meters? And way up here, this is 0. So he's laying like this. And this is where the guts and the stomach and all that nasty stuff is that decomposes. And that is the stuff that's really combusted. Up here, they can have these little fractioning earthquakes, and they do have an exit for all of the excessive heat. There's a ton of seismic activity up here, just boiling geysers and things, getting rid of that heat. But is it being heated from below, or is all that heat just from above? I say it's being heated from below, and the whole thing is just expanding in heat. Now, these could also be additionally heating over what they normally would be as well. But I'm going to tell you right now, in my opinion, you're going to have a lot of heat coming up from here, adding to whatever heat is here, and boiling up through there. Now, if you read all of the surveys and the reports and everything, they talk about sort of stationary, sort of stable situations, and all of a sudden something will almost like break and gush different fluids and different gases, and that's basically what eruptions are. But there's a lot of small ones as well. Now, they're shaking this ground with a 53,000 ton truck. I don't think that's the greatest idea. And they even say, right in the article, it says we were setting off mini earthquakes. Now, they're down on top of, well, they're up here. But and they can see and sense back that this fabric has holes in it. It's a porous cap on top of the magma that's inside there. Well, you're going to have it down here too, but you don't have these kind of caps. This is a very, very heavy fabric. Heavy, heavy, heavy fabric in your lungs. You have a ton of connective tissue, and it just does this all day long. And there's a million, literally millions of holes inside that lung, and all the rest is connective tissue. And this is basically a lung that has been stripped of all of its fluids and so forth. But even in where all of these little solid looking places are, there's thousands and thousands of holes, and that's the main entrance into this lung. And it's a mudfossil lung, but it'd be laying there dead just like that. And right up here would be the throat, and up here is the thyroid around a guy's neck, and right there is the hot springs where the mouth boils off all the water. Is this going to be a problem? Maybe. But I wouldn't be shaking things up here with a 53,000 ton truck. I don't think it's a great idea. It's interesting to know they did fine because it supports everything I've been saying. Okay, my friends, this is not understood well, and they see all these layers and they think, well, that's successive lava flows. And that's what it says here. The image displays distinct layers of igneous rock, a result of successive lava flows. This is in Russia. And this is, to me, clearly biological and tissues. Why would it erupt all these different types of things? Well, first of all, it's not. Just forget. It's just not true. This is the same as this, only it's a smaller version. The creatures were absolutely enormous, and they were smaller. This is still enormous. This thickness right here, which pretty much is a membrane, that you could hold up and be able to see through like a window pane. Inside that membrane is a ton of fluids. This is something like here, and then all the fluids. It's something almost like this right here is here. And then up above it, you got all these fluids that flow through the body. It's called the fluid-filled highway. It's red now because it looks like blood has infiltrated it in there. But this is the fluid-filled highway. And then above that, you have more layers of tissue. You see it up above there. And they have eroded away. It's being eaten away by the ocean or wherever it is. And this appears to be, like, say, the basement somewhere down in here. But these are layers of tissue, and the layers of tissue in your body are just stunning. Now, I am going to come up real close to this because I think this has got a lot of muscle in it as well. You see the block-looking stuff? Look at how many layers. Look at how many layers. What you want to look at is blocks. I think these are sarcomeres. And these are the blocks. And they're very fresh. And there's a lot of connective tissue in between. Those little stripy things are connective tissue. And then there's a layer of fascia, then that, and then a layer of slurpy stuff above that. And then muscle tissue, muscle tissue, muscle tissue. That's just the way it works. I believe these two things are very, very closely related. This one has more muscle than this one, I think. This looks like a lot of fat, possibly. You see the layer? I don't know what that... This stuff here, I don't know. I don't know everything about it, but I can tell you what, that is biology, and so is that. That I am very, very sure of. Well, all right, I'm going to jump right into this because I think this might be a little on the serious side. This is Yellowstone's magmatic system over the past 631,000 years. Well, they didn't realize it's getting much more active than they had thought. And it's a much bigger pool of magma than they had thought. And they just did a big study of what's underneath the earth here, and it looks to me like it could be kind of serious. Now, a new vent just opened up a couple of days ago, and it's got a light blue, milky looking blue color in it. And it's not real hot. It's only 109 degrees. But there was something they did up here that very few people understand. They went in and did a seismic survey. And you say, oh, that's good, they did a seismic survey. Yes, they did. And they found out that there was a lot of magma that they didn't know about. Hold on one second. All right, this is from the National Park Service. And Yellowstone, I've shown with this new survey they did out there to find out where the magma is, how much is there, and then they realized there's enormous magma chambers they never knew were there yet. Now hold on, listen to this now.
There's more magma underneath Yellowstone than scientists anticipated, a new study found. Yellowstone caldera's magma reservoir contains substantial melt at depths that fueled prior eruptions. However, scientists don't think this means an eruption is more likely than previously estimated. Instead, the findings may help to improve the model of the supervolcano and its associated hazards. Where and how much magma is below the surface is critical for assessing eruption hazards. Scientists still have questions about the volume and distribution of melt and conditions from prior eruptions. 3D modeling of seismic waveforms has allowed a new approach to topographic imaging. As in the study, this presents new images of the liquid parts of magma beneath Yellowstone. Now, scientists estimate a partial melt fraction of 16 to 20% more than previously anticipated.
All right, let me mention something to you. They still have questions about the volume and distribution of the melt. Well, we're going to be looking at the basaltic melt and rhyolithic melt and all that business. Now, they took, I think it was 30,000 tons, I don't know, a lot of tons, a truck out there, and they vibrated the ground. And they showed it here, like the surface waving like this. And they did that, they said they set off a zillion little earthquakes. Now, is that a good idea? I don't think it is. I mean, it's nice to know, but you see what they're saying? The 3D modeling seismic waveforms. They had a 30,000 ton or whatever it was. We're going to look into it. Shaking the ground. And what they got back, they knew how hard something was. And they found there was a dome. All right? You don't know anything about this, do you yet?
No.
All right. So they found there was a dome over the top of this very serious...
A new approach to topographic imaging. As in the study, this presents new images of the liquid parts of magma beneath Yellowstone. Now, scientists estimate a partial melt fraction of 16 to 20% more than previously anticipated.
All right. It's a lot more than that. Hold on a second. All right. I'm going to tell you right now, all of the Earth is warming up, and as it warms up, the creatures' bodies, which are creatures' bodies or whatever's under the ground, is biology that is decomposing and it's expanding, and they're having slow motion earthquakes, they call it, which is nothing more than the Earth is bubbling up basically and splitting as it bubbles. And this is at Yellowstone right here. Now listen to this now. They're saying, listen.
Now, a powerful eruption caught on camera at Yellowstone National Park that sent debris raining down on visitors. Mola Lange has that story for us. Good morning to you, Mola.
Well, good morning, Robin. Yeah, that eruption proving spectacular and terrifying all at the same time. Scientists at Yellowstone National Park telling us this was a random event happening without warning.
Screams of terror as this geyser in Yellowstone National Park exploded without warning Tuesday.
There's boulders, rocks falling all over us.
Watch as the plume of black smoke quickly...
All right, all the rest is just hype. But when you see something like that, that is obviously a release of some kind of pressure or an actual explosion. In this particular case, my belief is it's a release of pressure. Where'd that pressure come from? It came from more decomposition. Well, at a certain point, they may do one here and over here and over here and over here, and then you know, it depends on the level and the speed of the decomposition. But that is not a good sign. In my mind, it shouldn't be popping like that. They've been doing this over and over and over, the same thing every day for a million years, you know, whatever they say. And all of a sudden this is happening. Well, we'll have to see what happens. All right, here it is. I don't know if I mentioned this or not. I think I did, about the hidden magma cap. They just discovered at Yellowstone National Park. Well, what's a magma cap? Well, we all know what magma is. It's volcanoes and so forth, which is melted basalts, rhyolithic, and all that business. Well, they know that there's something going on. So they went over there and discovered a magma cap at Yellowstone National Park that is likely playing a critical role in preventing a massive eruption in one of the largest active volcanic systems in the world. This is absolutely enormous and gigantic and volcanic. Now, the cap is made of molten silicate materials and supercritical water. It's a liquid that is like gas. It's a liquid like gas that forms after water exceeds the critical temperature of 374 degrees Celsius and is in porous rock. All right, now it's located 2.5 or 2.4 miles below the Earth's surface and essentially acts as a lid on top of whatever's below that. All right, you follow me? 2.4 miles down is the layer that separates above up to us from the guts below. It acts as a lid, trapping the pressure and heat below it, according to the team of researchers who uncovered it. So they found this layer. Above that layer is the other things that I showed you, which I claimed were their lungs. Now, how did they do it? Listen to this. The scientists found the cap by using 53,000-pound VibroZ truck, a device capable of injecting low-frequency vibrations like a through the earth, vibrating the earth. So low-frequency vibrations into the earth to study the geology of the volcanic system. Wow, that's a good idea. Let's study the geology of it. I go along with that. It's a very good idea. Now, how are they going to do it? By generating tiny earthquakes that send seismic waves into the ground. Well, what's a seismic wave? It's a vibration. Seismic vibration, like a bomb going off. You follow me?
That sounds like a bad idea.
It doesn't sound good to me. So they're sending seismic waves into the ground. The researchers are able to measure how the waves reflected off subsurface layers, shaking them all the way down to this hard core, and probably below that. Now, the scientists were surprised to see something physically happen at that depth. All right, said Brandon Schmidt, professor of Earth, Environmental Planetary Sciences at Rice University, co-author of the study, in a statement. Now, you see these different chemicals? That is sulfur dioxide. This looks like copper, and they're all from transition metals, and they're all from boiling off the stuff which has the blood, and it boils the rest of that stuff off and brings up the transition metals as almost like gases. Sulfur comes up here, basically sulfur dioxide gas, and then crystallizes, and I'm sure the copper and so forth does too, but I'm not positive about that. But they read the gases. They test for gases. How much gases it's emitting. That means how much pressure there is. That means how much the vaporization of that particular. You understand what I'm getting at?
Yeah.
All right. So they're shaking this.
How long were they shaking it for?
Well, and long enough to be able to see those lungs and everything else. Now, I said in 2022, the researchers discovered Yellowstone supervolcano has substantially more magma reservoir. I'm going to show you why. Very simple to understand. I was just doing a video on this, and it's under the caldera. Under the caldera is the, you know what a caldera is, the bubbling spot that's bubbling out of there. That it's actually the mouth.
I was going to say the lungs is where the lungs is holding the magma, right?
Well, the lungs, the heart, the liver, the trachea, the thymus, you can see all of that very, very clearly, and then all of that bubbles up and boils out of the mouth up above, which was it is the caldera, the hot springs, all right, which is back here somewhere. This stuff here. Now, it's got a bunch of places it's boiling out of, but the key is, like, there's another one over here. It's got to vent out of there. If it doesn't vent out of there, it will explode. And even if it does vent out of there, it could still explode. And when you're shaking and vibrating the ground and creating many tiny earthquakes that send seismic waves into the ground, when you have a cap that essentially acts as a lid, trapping pressure and heat, and you're shaking it, I don't think that's a great idea. And
Not supposed to shake soda.
you just hit it, because they said they found that it's like a whole bunch of bubbles under there. And that's exactly what tissues are. They have all these bubbly, trappy spots in them. And they found it, I forget if it's in this article or not, but it talks about what they did discover under there.
They just think they have no idea that it's, biological tissue. And
Here, look at it here. Listen. They are idiots. Through modeling, the researchers determined a magma cap, which is the thing that keeps this thing from exploding, consists of molten silicate minerals, which are platy and polar and fracturable. Molten silicate materials. Well, if they're molten, that's a different story. And supercritical water bubbles within porous rock, and they're shaking it. Bubbles within porous rock. It's going to collect into little bubble pools and come up, and one just did, and it's blue, milky blue magma pool. It just came up, I think, a couple days ago. The bubbles are formed as the magma rises and decompresses, causing gases like water and carbon dioxide to separate from the melt. They're shaking it, just like you said, like a root beer, like a soda bottle. And they separate, the bubbles separate. Can you imagine they don't understand this?
sounds like.
Listen. Here it is. Volcanic eruptions occur as the bubbles accumulate and increase in the buoyancy, driving an explosion. And they're down vibrating them to collect into a ball in this porous rock. I don't think that's good.
Well, they're experts.
Well, I don't know. I hate to, they dismiss you because you ridicule them, but, somebody's got to speak up. Somebody's got to talk about it. Nobody understands this. Nobody does. I don't care. Show me somebody who does. Nobody does. It's me and you and a handful of others that have been paying, and you've been paying very close attention. You're about as skilled as anyone that I know about understanding all of the different facets of it, because it's not just one little thing. There's every, I don't know, how many of my videos you think you've seen?
Oh, like pretty much all of them.
No.
Yeah, I mean,
You're not
like 3-4 years. Yeah, I pretty much like every one of them.
You're not that old, man.
Just every one. Just you had so many shockers as yours that I just couldn't stop one after the other.
I know. I was just everything that I would look at. I found that's not right. That's not right. That's not right. That's not right. And everything I brought up, I said, let's talk about this. Nope, no talking. And I just couldn't stop. And I still can't stop because it's still the same condition today as it was then. If they don't want to know about it, they just don't want to know about it. Don't come around here with that stuff. And
They don't want you to know what a rock is.
how national parks and forests could suffer as a result of federal firings. Well, I don't know. Anyway, I got to go in and eat, brother. So,
Awesome.
hold on a second. I'm going to shut this down. Okay, my friends, I guess we're just going to get right into it. This is about the magmatic system, magma, volcanism, underground boiling mixture of chemistry, rocks all boiling and bubbling underneath. And they're saying the magma reservoirs beneath large volcanic systems like Yellowstone, large volcanic, are not simply large tanks of molten rock, like a big ball of just melted everything, but rather they're dynamic mixes. They're mixes of melt and crystals. They can change drastically over time. Well, let's take a look at what they have just discovered about Yellowstone. Now, don't forget, they're not just one big ball of a certain type of magma. There's systems. There's basaltic magma, there's rhyolithic magma, there's transitional melts. And we're going to look at it right now because they did a survey, and I'm going to tell you right now, they're having a hard time to try to deal with the results, but the results do not lie. All right, I have absolutely no idea what they mean here. I can take it two ways. They're talking northing in meters and easting in meters. So these are meters, and by times 10 to the fifth, they got to make everything so confusing. And these are meters times 10 to the sixth. Well, first of all, we know what a meter is. It's a little over 3 feet. Now, are they talking about 1 meter because they're starting at 4.88 for Y? I have no idea. Are they starting at that and going to there? That would mean it would be approximately 1, a little more than 1 of these northing meters times 10 to the sixth. That's a certain measurement. Or is it 5? Are they going up to almost 5? Is that the distance? I don't know. I really don't know. This I can understand. They're talking about depth in kilometers. Kilometer is 1,000 meters. And they're at 10,000. If this is right, this is 10,000, 20,000, 30,000, 40,000. Now, is that in a block? I imagine it is. So let's say we're at 30,000 here. All right, so that's 30,000 meters, which is 30 kilometers, 30,000 meters. All right, so 30,000 meters. I go by feet. So if you took 30,000 meters, I go 5,000 into 30,000. You get 6 miles deep. 6 miles to here. That's pretty damn deep. If that's what they're saying here. 6 miles. Now don't forget, if this is a creature's body, it's still got a whole batch of stuff behind this and under it, because it's basically on a rise like this, I believe. And it might be that this is what's this, I don't know. I have no idea, to be honest with you, at this point. But well, let me put it this way. If you look at this and you go straight across, this stuff is up above 10 kilometers, so 10,000 meters. This is low. All right, so basically it's tipped down this way. Think about it that way. It's tipped down this way. So if the guy's head was up here, he's laying like this. All right, so just think of it, he's like this. Blood is collecting down in here, but it's got a place it can exit through that vent. That is the only salvation here. And this place is littered with hydrothermal vents. Now, I would like to understand how they're talking about this, but I would say this is at least 15 miles. And it could be much bigger. It depends on how you read what this scaling is. Okay, like I said, I have no idea how they designated these distances, but apparently they're calling the caldera approximately 30 to 45 miles in the size, 50 to 70 kilometers. Now, but the caldera is only a part of the larger Yellowstone Plateau volcanic area. How big that is, I don't know. But 30 by 45 miles is the really hot spot area. It appears to me. That's what they're saying. Okay, this volcanic plateau includes the caldera, spans parts of Wyoming, Idaho, and Montana, and is characterized by multiple calderas. These are like little cauldrons with lava domes in places and numerous volcanic features. When I see volcanoes, I see decomposition, I see festering, I see heat, explosions if they're capped. And they're talking about capped formations they didn't know about before. These lava domes, they're not really lava domes, but they do the same thing. They are caps under the earth. All right, we're going to go back to the survey, but remember this. There's two magma bodies that they have found. There's the basalt and there's the rhyolite. The shallower one, which is up closest to the surface, is composed of rhyolite. It's about 3 to 10 miles deep. That's the one up the closest to the top. It stretches 55 miles long and 25 miles wide. Yikes. The deeper basalt chamber is much larger but contains less molten rock. Alright, the two of them, you hear what I say? Less molten rock, because it's more structural. But the other one is less structural and up above the one that's molten and is much bigger, much larger. Well, they don't even know about the ones that are below that. Alright, let's refresh ourselves. They're saying that these are much bigger and they're deeper and they're called basaltic melt. And they have less actual magma in them than these up here, which are called rhyolithic melt. And I claim the reason is these are much more structural because they are pumping blood and absorbing, and they have all these alveoli and tubing running through. Very, very a lot of stuff going on inside of a lung. All right, now, inside of the heart and so forth is primarily blood. And that gets into real magma because it's just nothing more than a fluid chamber. This just has a lot more structural integrity. Only difference. It's still got a ton of blood. Now, this I don't know whether this is the split lung or, a heart, or it's a couple of pieces of organs up here, but we'll go with that in a minute. This right here, it's absolutely flawless, identical to the thymus that wraps around the throat of a creature, and then they spit out here, or they do whatever they do. Now that could be his earlobes, it could be his nose, it could be his mouth, whatever. But that's where the hot springs are coming out, because everything is boiling in here. It's all boiling. Now, what they didn't take into account is the fact that, well, first of all, they just not in their mind to be able to accept that this could be a creature's body, and it is a creature's body. Now, there is a layer underneath here. I believe they found, and they agree, there is a lava dome. It's a cap for deeper lava, and they're right. There is some serious lava, and it comes from the intestines, the stomach, the colon, the bowels. The whole guts of the creature is below that. All right, apparently in April 2025 this year, geologists identified a new thermal feature. Now, apparently they say it just popped up here July 14th. It became a new crater in the geyser basin. And it's this blue fluid here. And I never saw it before. Apparently it became seen May 12th, 2025. And these are the February, December, yada, 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 whatever. That is another feature that just popped up. And then they had a big, basically a very serious-ish pop while the people are out walking around on the boardwalk here, and it went off big time, really. To me, it would have been extremely scary, let's put it that way. Okay, check this out. This goes back, about a year or so ago.
A sudden, massive geothermal explosion at Yellowstone National Park Tuesday sent tourists, adults, and even small children running from flying rocks and debris.
Run, run, run! Run! Run!
This part of the park is called Biscuit Basin. It's an area of hot springs, pools, and geysers just up the road from Old Faithful. That area is now temporarily closed, and photos showed rocks and debris and damage all over the boardwalk.
Not good. Okay, my friends, this did very strange. This just came in just minutes ago. Yellowstone's hidden earthquakes. 86,000 quakes revealed by AI. Now, it says scientists used AI to reveal tens of thousands of previously undetected earthquakes beneath Yellowstone. The discovery shows swarming seismic activity across immature fault lines, transforming how we see the park's explosive underworld. Now, I have been studying all the recent seismic studies that they've been doing, and they've been doing a lot of them. And it sort of tends me to think that they might be suspecting some activity. They are downplaying it, but I want to show you what I did find, and that's the video I just did. It was all done, it was ready to go, and then this pops up. So, get ready. Okay, I'm going to try to wrap this up here. As I say, I just got this in about this 86,000 earthquakes. Now, they're saying a key finding was that more than half of the earthquakes recorded were part of earthquake swarms, little pops in a certain area. They're groups of small, interconnected earthquakes that spread and shift within a small area over a relatively short period of time. All right, so they're sort of just sort of doing that. It's unlike an aftershock, which is a smaller earthquake that follows a larger main shock in the same general area. So they don't have a large main shock and then da-dum, afterwards. No, they just have the ground is just disruptive in a certain area, causing these little shocky things in an area that's just basically expanding. And what it is within that area that it's expanding, there's something in there that is pushing it out. I mean, it's just the way it works. Or it's caving in. That's a possibility too. But I don't think so in this case. I think heat and moisture down in that level is forcing everything to expand, and the more heat that's down there, the more expansion, and there is more heat down there than there ever was before. The Earth is overheating. Okay, this is the update, June 2025. This is Fair Use Act. I'm not trying to steal anything from them. This is the U.S. Geological Service. We're paying for this. I'd like to see what they have to say. Here goes.
A lot of hot water here in Yellowstone. And what's it powered by? A magma chamber beneath the surface. Turns out we know an awful lot about this magma chamber too. It's one of the most studied magmatic systems in the world. Scientists have bounced seismic waves off of it. They've done seismic and electromagnetic imaging, sort of like taking an MRI of the Earth to see the properties of this magma chamber, and it's revealed quite a lot about the way this system works. Now, when we draw magma chambers, it's usually sort of a red balloon right under a pointy mountain. It's not really what they are. It conjures this image of all melt. But in reality, magma chambers are complex mixtures of some melt, a lot of solid crystals that have precipitated out of that melt, and even some gas, sort of like the carbonation that comes out of a soda. And based on all these studies at Yellowstone, we know that the magma chamber is about 2.5 miles beneath the surface, and it's mostly solid. It's only about 20 or so %, give or take, molten, and those molten lenses are stored in various horizontal layers within that chamber. So not a lot of actual melt in the Yellowstone magmatic system, but it's still hot. It's enough to heat water that circulates down there and give us the spectacular geysers and hot springs that we see behind us today.
All right, the thing is, they're not taking into account what's below what they have mapped. And what's below is much more expansive than what they have mapped. They're talking about mostly rock with not so much fluids and volcanic activity in this upper melt area, but the lower melt area will be almost 100% melt, and it's brewing down there. I can tell you that. There's pretty much no question, and that's a lot of that is what's powering the system above, is my opinion. Now, what I'm hoping for is to get some discussion. I can show you anatomically exactly what this is, and I am 100% certain that it is what I claim it is. And if you wanted to watch this, you would be too. Now, don't forget, this is what he's coming out on, and it stops here, and then it dips way, way, way down to that red bed. All right, let's look at what he's looking at here. Now, you notice the red, you notice the black, you notice the blocks, how perfect they are, how they match up together, and their lines and stripes, and then it goes way, way down to that red bed. All right, and here he is standing on it. There's his dog. All right, look at the size of this. Look at the size of this. Look at these perfect squared off blocks. Look at the colors, the red and the black. Very important to understand the biology that you're seeing here, and that is biology.